welcome you all, students. So today topic we are going to discuss about the Fischer projection and flying wedge projection formula and its interconversion. As you know, in earlier lecture we discussed about the Newman structure and Sahor's projection formula. So here today we will discuss about Fischer projection and flying wedge formula. So if you see overall the discussion will be in the majorly we will discuss on Fischer projection formula, flying wedge and its interconversion, because this is very important. Once you see the different type of stereo or different way of how to look the molecules and their stereochemistry. So in this topic we will start from to see how the Fischer projection is depicted in case of a molecule. So here, if you see these molecules here, so you can see these molecules which is in a vertical line and horizontal line. You have to just see here, these are towards the viewer side, means from your eye side if you look at this molecule, and these molecules or these atoms or groups which is attached with this carbon is away from the viewer. So here the characteristics feature of Fischer projection is you have to rotation of a Fischer projection by an angle 180 degree about the axis which is perpendicular to the plane of the papers, and it gives a identical structure. However, simulate rotation by an angle 90 degree produces non-identical structure. So if you see this structure, these are these dotted line is shows the atoms or group backside the viewer, and these are towards the viewer. So this thick line shows that the atoms or molecules whatever is attached in case of even in other molecules, so we have to see the molecule in this way, and then we will come to in a major discussion about how the Fischer projection is depicted, how to see the stereochemistry. So here you just be aware of that in case of a flying wedge formula, so it is a 3D representation of a molecules. So the flying wedge formula, if you see, this is having two enantiomeric, like in case of lactic acid are shown here. So here if you see, these are the weak line you can say, and this is a thick line, and this is the normal lines. So this represent on the paper, and this is outside the rear side, from where suppose you are looking this molecule. So this is towards you, this is above the plane, and this side, this is backside the plane. So both these structure are mirror image of each other. So if you just put a mirror here, so you will see these are the mirror image of each other. So the main functional group is generally held on upside in a vertical planes. So here once you here, now the Fischer projection of a compound can be converted into Sahor's projection, or first in the eclipsed form, or by holding the model in horizontal plane in such a way that the groups on the vertical line point above and the last number chiral carbon faces towards the viewer side. So by taking this example, you can see here, because this is the Fischer projection in which these are the rear carbon, this rear carbon, and this is the viewer from the front side carbon. So with this carbon there is three different groups, similarly here three different groups. So how to represent in forms of Sahor's in case of eclipsed form or staggered, because there are two forms, eclipsed and staggered form. So here what is the difference between this eclipsed can be converted into the staggered form by 180 degree rotation along the C2 C3 axis, this C2 and C3 axis. So you can see here, like this carboxylic group and this carboxylic group having the same direction, and this is making a inverted Y. So if this kind of structure is being formed, so that is called eclipsed form. And if this one carbon which is having inverted Y and another is regular Y, then this is called the staggered form. So in this case, this type of orientation can be achieved by the rotation along the carbon 2 and carbon 3 bond by 180-degree rotation. So this kind of conversion can be made with the help of from one form to another form. So now coming to the another example, here many more example is there. So like suppose you have a staggered Sahor's projection. You can also convert like Sahor's conversion of Sahor's projection into Fischer projection. So by this way, by making the 180-degree again, like you can see here, like suppose this is having the methyl group and this hydrogen bromine you have to put this side, and these are from the left side group. So now first of all you have to convert this form into first eclipsed form. So once you will change this in eclipsed form, so you have to make the rotation by 180-degree. Like you see, methyl group is here, so this is going towards this side. So this total overall angle is 180-degree angle. And similarly, this bromine is coming to this side. So this is along from here, this axis, this is 180-degree also. So this hydrogen is coming this side, so it is 180-degree again. So by this way, you will get this structure and you can convert it into Fischer projection. So coming to another examples, there are many more examples you will see by which you can practice. You can just watch how the different kind of projections can be converted into different form. Like in Newman structure, you can also convert the Sahor's projection into the Newman structure. So these structure can be easily watched by converting like here. But if suppose you have a molecules which is having the staggered Sahor's projection, then if you want to change it into the Newman structure, then how you will do it? You have to see the molecule here. So in this case, the front carbon is put into in a form of this point, and the rear carbon is represented by this circle. So first of all, you have to see if there is a front carbon. So just watch this carbon, and this carbon will be represented as a point. Here you just put a dot, and now you have to put the molecule as it is, and you have to see the groups where they are aligned in the 3D space. So by putting these in a, like from here, you see there is a methyl group, phenyl group. So this phenyl group is represented here, bromine and OH. So similarly, this is being put like this way. And now it is, once you will bring it like this is a staggered Newman projection. So by rotating the front carbon along the central bond by 180-degree. Now what do you have to do? This front carbon you have to rotate by 180-degree. So what will happen? You have to see what is the changes will be there. So if suppose you are rotating in a 180-degree like this carbon especially, then what will be the change? This phenyl will come this side. So similarly here, this phenyl will come along this side 180-degree. So you can watch this changes, which is the eclipsed form of the Newman projection. So similarly, other group will go according to the same way, and they will change their positions. So this way you can convert easily the different forms by the interconversion. So in case of holding in vertical plane, keeping front carbon as the lowest. So by this way you can change this conversion formula to another form which is called Fischer projection. So you can see here from this carbon, the phenyl group is here. If you see this, OH will be on the left hand side from this vertical line, and this is on horizontal bromine atoms. So similarly you have to put the rear carbon. Now you have to see the rear carbon is this one. So here you can also put the same way, and then you will get the Fischer projection. So these interconversion are very important once you are watching the molecule in a different if you make them in a different projection formula with either in staggered, if you want it to convert it into the staggered form, or eclipsed form, so you have to change as per the proper rotation or proper rotation with respect to the certain angle. So by this way you will get the different forms of that particular molecule. So these approach can be approached with the various other kind of molecule as well. So by that way you will get the different projection for. So similarly here, if you see this Fischer projection, so this Fischer projection, if you want to put it into the eclipsed form, so you can change it into eclipsed Newman projection. So again, eclipsed means you have to see if the all the atoms or groups are very near to each other with respect to the rear carbon. So here the more strain will be there, but once you will put these carbon, or if you change this in a like a staggered form, then you will see the different groups are far apart from each other. So in that case there will be the lesser strain. So once the lesser strain means you can see as the basic as per the rule or basics of that, the carbon, if they are having a such kind of structure with the apart all the atoms or group are having apart from each other, then there will be less hindrance, and that molecule will show more stability. So by this way you can see the Newman projection formula, you can change it. And so by converting it, this Newman again into the staggered form in a Sahorst projection, so you have to just put the different groups, just this front carbon is put here and rear carbon you have to put by this way. So this conversion can be performed with the help of these set of rotation, set of watching the molecule in a with a proper form, then this can be converted into the another form of the molecule. So these conversions are very important with respect to see the molecules in 3D orientation. Now the vertical, if you see the vertical bond in Fischer projection are drawn in plane of the paper using simple line. So this is like a simple line, and consequently horizontal bond will project above and below the plane. So here if you see this is simple line or normal line, and here if you see this, so this vertical line you have to put in this form, because this is in on a paper, and this is behind the paper, and this is in front of the viewer, or you can say on the viewer side. So you are able to change this in wedge form, different flying wedge form, and these can be when hydrogen above the plane, because here you can see if you are putting the hydrogen, if you are watching this molecule from different directions, so this will be in towards you. So in that case this hydrogen will be above the plane, and in that case you can see this COH, CS3, and this bromine will come this side. So this bromine, once it will change, then their position is getting changed with respect to when you are uh, the, the when the different groups, like here in case of this is a bromine atom, or here in case of hydrogen atom, if they are above the plane, then the structure of the orientation, you can say, the molecule will be looks like this. So this is also you can have to keep in mind, once you are changing this, then this vertical line will come into a into the paper or 2D, in the 2D, because in a paper you can represent only 2D, but for like a 3D molecules it cannot be depicted properly, so you have to put it like in a desk behind, represents back side of the paper, and or you can say the rear side, and this is on the front side. So by this way you can change the molecules. So now you can see here also there is uh, by this way the molecule can be rotated in the vertical plane in such a way that the bonds shown in the plane of the paper go away from the viewer and are verticals. So here by this way you can see here again By if suppose you're having this set of molecules and you want to put it into the Fischer projection or in a form of vertical and horizontal line, then how you will convert it? So you have to see these points is very important here. So you have to follow these points and then you will be able to put this molecule. So here, because this hydrogen is represents the rear hydrogen, and this is the, you know, the front atoms. This is the front atom, which is bromine. So here this is the horizontal, vertical line. So you have to just put on the vertical lines, and this hydrogen will be on left side and this will be on bromine will be on the right hand side. So rotate the model in vertical plane so that COOH and CCS3 go away from the viewer. So now another terminology which is very important here, which we have to be discussed, and this is very important with respect to once we are watching the different configuration by changing the molecule from one form to another. So this is called absolute and relative configuration, because absolute configuration is also very important here to see what is the meaning of that and what is the meaning of relative configuration. So absolute configuration, it denotes the actual arrangement of the atoms or groups of atom in a space of a particular stereoisomer of a compound. Because if you are having a compound and that compound is having suppose different stereoisomer, so this is very important because this is the actual arrangement of the atom in case of a stereoisomer. And absolute configuration can be ascertained by X-ray study of, or the crystal of a pure compound. So this X-ray study, XRD, and these kind of study is very helpful to see the absolute configuration in a form of compound when it is in a crystal form or like that. So in a chemistry, if you are having a like some this kind of compound, so this can be this arrangement can be checked with the help of like X-ray studies. So with respect to, once we see the absolute, with respect to this, if we see the relative configuration, it denotes the arrangement of atoms or groups of atom in a space. In space, when we are talking, so it is like a in a stereo, means 3D space of the molecules of a particular stereoisomer related to the atoms or group. It means with that particular stereomer, whatever the atom is attached with that, or whatever the group, it could be in a form of atoms or it could be in a form of groups or atoms of another compound chosen as the arbitrary standard for comparison. So here this is chosen as a arbitrary standard for comparison point of view. So these absolute and you know the absolute and relative configuration is also very important to see the molecule. So now coming to this here, if you see the glyceraldehyde, this is an example is given here. The configuration like A, for example, was arbitrary assigned to designate the configuration of plus glyceraldehyde. Taking this as a standard, the relative configuration of this minus and plus represents the the rotation of the light with respect to the plane polarized light, either dextro or levo. So this lactic acid was assigned as sonpilo. So here you can say like this A compound is having like this is like glyceraldehyde. So arbitrarily assigned that OH group is on right hand and H is on the left hand side of this vertical line of this CHO group and CH2OH group. So with respect to this, we are talking here. So this is on the left hand side, and if you see, this group is on right hand side. So this is after oxidation in presence of bromine water. So what is the changes is being observed in such kind of molecules. So this aldehyde will convert into acids. So you can see here by the oxidation in presence of brominated water or bromine water, you can say here. So this is converting into this molecule. So now there, the stereo is minus glyceric acid. This is forming in the minus glyceric acid. So after, reacting with the bromine or phosphorus, so this is changing from the one, the bromination is taking place. This you can see here. So this is making CS2Br, and this OH group is being replaced from their position. So now this 1 bromo 2 hydroxy propionic acid, it is converted from, from starting molecule. If you see here, so this is further, once you will leads this further reduction. So this reduction will leads you the another molecule which is minus lactic acid. So this whole conversion is going with a certain, changes in the structure of the molecules. So that configuration is also getting changed from different, configuration which you have taken as starting, and it is configuring in another rotation, as I said in previously. So this is can be depicted, or this can be assigned as, as shown here with the help of this example. So these all terms which is being used here can be converted from one form to another by changing their different, different organic synthetic route or organic process route. You can say there are different synthetic process. So these kind of changes can be observed during the synthesis, or during to make certain kind of product formation, because during that there are certain changes is being takes place with the help of by using different reactant and different reagents. So their stereochemistry is also getting to be changed from one particular form to another form. So this is very important to see how the configuration, is getting to be changed from one form to another. So this you can see from the overall discussion of the lecture. From the topic, we have a discussion on Fischer projection and flying wedge formula, because this is Fischer, how to represent the molecule in a Fischer projection, and what the, how the way we can change from flying wedge formula from Fischer to flying wedge, their conversion from, Fischer projection into flying wedge uh, projection formula, a conversion of vice versa flying wedge to Fischer projection. So these conversion is very important, because these shows how we can change the molecule with respect to, putting in a different orientations by with a set of rules we have to follow up, and then we can change these molecules from their different orientations. And since in a case of, like in a case of molecules, you had seen also there are terms being used like staggered and eclipse form. So these eclipsed and staggered forms, we had seen how to change from one particular forms to another form, because this is also very important. Once we see whether the molecule will, in which condition it will be more stable, and how could the molecule is having their less energy with respect to their different projection representation. So in which projection formula it will show the least energy, and that's why that will show the most stability with respect to the another special form of that molecule. So by this way, like we can also, these conversion also helps to see the different stereochemistry, like you can change their, the rotation of the light, how the rotation of light is being, they show different rotation pattern in plane polarized light. So this is what we have a discussion on this. So apart from this, we also have a discussion on absolute and relative configuration. So you've seen that what is the absolute configuration, because this is the original, or this is the actual arrangement of the molecules or groups or atoms in a particular kind of molecules in which we had seen that this is the actual arrangement with respect to that's, if suppose that's a central carbon, if you are assuming, so with respect to that particular carbon uh, in that molecule, how does the different atoms or groups are attached. So this is the actual, you can say, the actual arrangement of the atoms or groups. But relative configuration, so this is having a with respect to some particular groups or atoms or molecules which we have. So this is with respect to the relative, if we are watching the molecule, how relative is that configuration with respect to the original one or with respect to the original of the molecule. So here, if you see, we have after the discussion, there could be a number of questions can be framed out, and the answer can be answered from these all discussion. So like the question which is being generally can be formed here is like to illustrate the projection of Fischer and flying wedge formula. So from this overall discussion, we can able to draw these structure, these formula, and we also like show the conversion of Fischer to flying wedge with suitable example. So by this you can also answer these kind of question, how this can be converted from one form to another, and how in a different kind of molecule, if you are taking with a suitable example, any example of the molecule, so how can we change from one form to another form. So another, if you see the differentiate between like absolute and relative with respect to configuration, we can also see how to absolute and relative configuration can be checked out and how can be explained. Here, these are the sources and references from where these slides has been made. So this material is which presented here is only is for the instructional purpose only, and they are having no any commercial use. So since this is taken from the various books and internet sources, online content and different sites, and books has been referred here, different reference book. So these all books has been taken to make these different images and graph or related reactions has been taken from there only for the instructional or teaching purpose only. So I thanks to all of you for watching this video and listening this video lecture. Thank you so much.